autoencoder. So autoencoders, neural network, it is an unsupervised machine learning. Autoencoders, they are used to reduce the size of input into the smaller representation. We have seen earlier that encoder, it is basically divided into three parts. One is the encoder, the last one is the decoder, and in the between we have the code. So autoencoders, they are an unsupervised machine learning technique in which we leverage neural network for the task of representational learning. Specifically, we will design a neural network architecture such that we impose a challenge in the network which forces a compressed knowledge representation of the original input. Here in this, we have a bottleneck in between. A bottleneck, it constrains the amount of information that can traverse the whole network, forcing a learned compression of the input data. So autoencoder, they are unsupervised learning algorithm which, what do? They reduce the size of our input into the smaller representation. Obviously, if we need the original data, we can reconstruct it from the uncompressed data again. The idle encoder model, it basically balances two important things. First of all, it is sensitive to the input enough to accurately build a reconstruction. Whatever inputs are being provided to it, it will be sensitive towards it. Sensitive means here that some important information should not be missed out. Since it is trying to make a smaller representation of the input, so it must be made sure that it build a proper smaller representation and no important feature is missed out. So we can say it should be sensitive to the input enough to accurately build a reconstruction. Second, insensitive enough to the input that the model does not simply memorize or overfit the training data. Now, to the input, it should be insensitive also. To what extent? That it does not simply memorize or overfit the training data. That means the whole data that will be provided will be converted into the code. So that should not be there. So the trade-off between these two conditions, it forces the model to maintain only the variations in the data required to reconstruct the input without holding on to redundancies within the input. For most cases, it involves constructing a loss function where one term encourages our model to be sensitive to the inputs and the second term, it discourages the memorization or the overfitting. That is why we use an added regularizer here. So a proper regularization term is being inputted in this autoencoder to adjust the trade-off between these two conditions. What are these two conditions? That it is sensitive to the inputs enough to accurately build the reconstruction, insensitive to the input so that the model does not simply memorize or overfit the training data. So the trade-off between these two conditions has to be maintained properly, and this is done with the help of a regularization term. Talking about the types of encoder, we basically have here 4 types of autoencoders. The first one is under-complete autoencoder. It is the simplest architecture for constructing an autoencoder. What does it do? It is used to constrain the number of nodes in the hidden layers of the network, limiting the amount of information that can flow through the network. So an undercomplete autoencoder, it has no explicit regularization term. We simply train our model according to the reconstruction loss. So the main condition for this undercomplete autoencoder is to constrain the number of nodes which are present in the hidden layer of the network. Second one, we have the sparse encoder. Our sparse encoder here, it offers us more information, introducing the bottleneck. without the human intervention. It takes all the nodes from the hidden layer, and we here penalize the activation within the layer. So that is the main function of sparse autoencoder. Talking about the third one, that is a denoising autoencoder. Denoising means create a computed copy of the input by inputting some form of noise, or we can say introducing some form of noise. What does it do? It helps to avoid the autoencoders to copy the data, the input to the output, without the learning features about the data. So these autoencoders, they take a partially corrupted input while training to recover the original undistorted input. Here automatically some form of noise is being introduced, and so this model learns a vector field for mapping the input data towards a lower dimensional manifold which describe the natural data to cancel out the added noise. Then we have the last one, that is a contractive autoencoder. So the main objective of this contractive autoencoder is to have a robust learned representational learning to create a small variation in the data. So that is the main purpose of this contraceptive autoencoder. So we do have some more types of autoencoders also, but the most frequently used are these 4 types of autoencoders that we have just discussed. Next comes a very important term, that is NLP. NLP says natural language processing. It is a part of computer science, human language and artificial technology. This particular technology, it is being used by the machine to understand, to analyze, manipulate and interpret the human language. Natural language means the language of the humans that the machine is trying to understand. There are basically 2 components for it. First is NLU, that is natural language understanding. Second is NLG, that is natural language generation. NLU, it helps the machine to understand and analyze the human language by extracting the metadata from the content, like the concepts, like the entities, some form of keywords, some form of emotions, relations and the semantic roles. So this machine natural language understanding, this particular component, it helps to the machine to understand and analyze the human languages. Next one we have natural language generation. Now this one, it acts as a translator and it converts the machine data or the summarized data into the natural language representation. That means it is generating this natural language by understanding the different words provided to it, by understanding the different sentences, making sentence planning and all. It is trying to generate the natural language. So the main 2 components of NLP are natural language understanding, where the machine it helps the machine to understand and analyze the human language. Natural language generation, that means it is generating the natural language. So that is another component, NLU and NLG, natural language understanding and natural language generation. Now comes the various applications of NLP. Where all do we use this natural language processing? Where all are we using it? The first area where it is being used, it is question answer. For the purpose of question answering, it focuses on building the system that automatically answers the questions asked by human in the natural language. Like nowadays, whenever you go on the airport, there's a robot moving, which will give you answer to the question that you ask in your natural language. You might ask that particular robot that where can I find water? Where can I go for web check-in? So that this sort of natural language questions will be answered to you by the robot itself. So that is the area where we are using this natural language processing. Second one, spam detection. What is this spam detection? It is used to detect the unwanted emails getting to the user's inbox. Every time so much of emails you receive in your your mailbox, then how does it get categorized into spam and your inbox? So that is one application where we are using NLP. Third one is sentiment analysis. It is used on the web to analyze the attitude, the behavior, and the emotional state of the sender. So, for the purpose of sentimental analysis, we are using our natural language processing. Then, machine translation, it is used to translate the natural language to any other language. It might be used, machine translation means it is translating from one language to another. So there again we are using our natural language processing. The last one is speech recognition for understanding of words, for understanding of speech, and to categorize into the words or the text. There again we are using our natural language processing. So these are the few applications of NLP.